Scientists spot a black hole energy beam as bright as 1,000 trillion suns pointed towards our Earth. So-called relativistic jets of energetic particles are stunning, destructive spectacles, and this one was unprecedented, Becky Ferreira on Vice.com reports. On a clear night this past February, a sophisticated astronomical camera perched on a California mountaintop opened its eyes to the sky after being shut down for several days due to glitches. The timing turned out to be impeccable, as the camera, which is part of the Zwicky Transient Facility, ZTF for short, immediately spotted a dazzling eruption of light and energy in the distant universe that was unlike anything that has been seen before. When ZTF astronomers logged into their work Slack the next day, they shared their delight with the brilliant discovery, as well as their puzzlement about what might have sparked this flash that shone with the light of 1,000 trillion suns. They said, "My first message on Slack was, we are restarting with a bang." This is what Igor Andreoni said, as an astronomer at the University of Maryland, who works at ZTF, in a call with Motherboard that also included his colleague Michael Collin, an astronomer at the University of Minnesota. He said engineers worked without stopping, weekends included day and night, to make the camera operational again, and literally the first night it was operational, there was this detection. Now a team co-led by Andreoni and Collin report that this mysterious flash was actually a powerful energy beam, an immensely energetic jet made of ultra-fast particles, and it was pointed at Earth, fueled by a black hole eating a star many billions of light years from our planet. This type of radiant cosmic phenomenon is called a tidal disruption event, or TDE for short. The researchers concluded that this unusual blast, named AT 2022 CMC, is the furthest jetted TDE discovered so far, and the only one for which it was possible to observe a complex optical light curve that transitions from a fast red component into blue plateau, according to a study published on Wednesday in Nature magazine. A companion study, which was published in Nature Astronomy at the same time, presented a detailed model of the birth of this jet. The surprise discovery reaffirms the necessity to have truly eyes wide open searches of these vastly growing astronomical databases we have, said Collin in the call, noted that he and Andreoni were looking for a completely different type of astronomical event in their ZTF survey. He said this is a great example in astronomy of a willingness to look outside the box for exciting things. It's a source we did not really think hard about until after it was discovered, because it's so rare, Andreoni noted. It's not quite the first thing you think about, an event that is detected once every 10 years, if that, and that has never been discovered before in the optical wavelength. This is unprecedented, he said. Though black holes are often invisible to light-based astronomy, they can paradoxically produce some of the brightest light shows in the universe if they get into feeding frenzies. Stars that wander too close to a black hole may get torn apart by the intense tidal forces in these extreme environments. As it consumes the starry meal, the black hole can shoot out relativistic beams of particles, meaning that they travel at close to the speeds of light. Jets that are pointed directly at Earth can be visible across huge distances, though none has been quite so far-flung as AT 2022 CMC. Follow-up of the event captured by the European Southern Observatory's Very Large Telescope revealed that this particular jet was born when the universe was only a few billion years old. In addition to breaking the distance records for TDEs, the presence of so much visible light from AT 2022 CME opens a new window into the mysterious mechanisms that power these jets. This is already telling us a story about the environment surrounding this very massive black hole, Andreoni said. It also tells us about the time scale of formation of the jet as compared to the disk of material around the black hole that accretes and keeps pumping out energy that we can observe. The other nice effect is that, of course, it's very challenging to estimate how often a jet birthing happens, Collins said. People had made these estimates based on the detections in X-rays in the past, but the Zwicky transient facility has been running for 4 years or so now, and we've seen one of them in optical light. This actually puts quite strong constraints on how often they can happen. With these new revelations in hand, astronomers are better equipped to search for more of these mind-boggling events across the universe, which will help to unravel their explosive secrets. We're trying to contribute to a coherent picture of all these tidal events that we observe, with and without jets, Andriani said. This is an important question because the moment you find the connection, then you can have a much better insight on what's actually going on when a star is disrupted by a black hole. We just need to observe more and deeper, he said. I think we'll get much closer to understanding why they're so rare and the astrophysics of these events. And this is on Vice by Becky Ferreira. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box.